Dear students, today's lecture is on the module on principles of spectroscopy. In today's lecture, we will be discussing about the introduction of spectroscopy, its definition. We will be talking about electromagnetic radiations, and from these electromagnetic radiations, how the origin of spectra takes place. First of all, what is spectroscopy? Spectroscopy is a branch of science which deals with study of interaction between electromagnetic waves and matter. It is a powerful tool for the study of atomic and molecular structure. Each spectroscopy has different bandwidth of radiation and is used to determine the different chemical and material properties. Spectroscopy is a branch of science which is concerned with the investigation and measurement of spectra produced when matter interacts with or emits electromagnetic radiations. So we should know or have a basic idea of what electromagnetic radiations are. Electromagnetic radiation is a type of energy that is transmitted through space at enormous velocity, does not require any supporting medium for transmission. It can pass through vacuum, consists of electric and magnetic waves oscillating at right angles to each other and at right angles to the direction of propagation of radiation. To study the electromagnetic radiation, first of all, we should know the basic properties of a wave, which are amplitude, wavelength, and frequency. This is a figure showing electromagnetic wave. This is a wave which is being shown. The wave has a trough, which is the lowest point, and a crest, which is the highest point. The vertical distance between the tip of the crest and the wave central axis is known as its amplitude. This is the property associated with the brightness or intensity of the wave. The horizontal distance between two consecutive crest or trough is known as the wavelength of the wave. These lengths can be visualized as we are seeing in this diagram below. In order to describe the basic properties of the wave, following quantities have been defined. First one is wavelength. Wavelength is defined or denoted by the Greek letter lambda. Wavelength is given by wave velocity upon frequency. In this diagram, as we are seeing that when the frequency is high, the distance between the wavelength is short. If the frequency is low, we are seeing that the distance between the wavelengths is long. That is what is mentioned over here. Longer the wavelength, low frequency, short wavelengths, high frequency. Next, we will talk on frequency. It is denoted by Greek letter nu. The frequency of a wave is the number of waves that can pass through a point in each second and is measured in hertz. It is directly proportional to energy E. E is equals to h nu, where h is the Planck's constant and nu is the frequency. We also have another factor, which is wave number. It is the number of waves per unit distance. It is measured using centimeter inverse and it is given by nu bar is equal to 1 upon lambda. Coming on to electromagnetic spectrum. Electromagnetic waves can be classified and arranged according to their various wavelengths or frequencies, and this classification is known as the electromagnetic spectrum. The following figure or a table shows us the spectrum, which consists of various types of electromagnetic radiations that exist in our universe and is arranged according to increasing wavelength or decreasing frequency. The electromagnetic spectrum is comprised of variety of radiations in the universe. Gamma rays have the highest frequency, whereas radio waves have the lowest. Visible light is approximately in the middle of the spectrum and comprises of a very small fraction of the overall spectrum. As we can see, the visible spectrum, that is the light that we can see with our eyes, makes up only a small fraction of the different type of radiations that exist. To the right of the visible spectrum, we find that the type of energy that are lower in frequency and thus longer in wavelength than the visible light. These type of energy include the infrared IR rays. These IR rays are heat waves given off by thermal bodies. We have got microwaves and radio waves. These type of radiations surround us constantly and are not harmful because their frequencies are very low. To the left of the visible spectrum, we have ultraviolet rays, X-rays and gamma rays. These type of radiations are harmful to the living organism due to their extremely high frequencies and hence they have got very high energies. It is for this reason that we wear suntan lotion at the beach to block the UV rays from the sun, and why an X-ray technician will place a lead shield over us in order to prevent the X-rays from penetrating anything other than the area of our body being imaged. Gamma rays being the highest in frequency and energy are the most damaging. Luckily though, our atmosphere absorbs gamma rays from the outer space, thereby protecting us from this harm.